Okay, ladies and gentlemen, I'm going to go through that daily reminder that your lectures are recorded online in case you want to review them, okay? You guys okay with that? All right, so what we're going to do here today, ladies and gentlemen, is kind of a small transition, but not really. We got some important ideas to transition to. This is about looking at that tangent line, okay? So if I go back, I wonder if I'm online here. Oh, there we go, 261. We're gonna look at some worksheets and videos here. Yeah, the tangent line. You remember we looked at this here? Okay, we looked at some of this notation. This is what we're going to do here today. We're going to work with this tangent line here. Now, you see that blue line? Okay, what kind of equation is that, by the way? Let me see if I can bring this in our note. Okay, let's try to do that here. All right, let's see. Okay, so today what we're going to try to do is we're going to try to find this blue line. Okay, now this blue line is known as a what? This is called the equation of the line tangent to the curve F. And you say, where's my curve F? It's right here. This is the black line, not your curve F. Okay, but it's the equation of the line tangent to the curve at the location A, F of A. It's at this particular what? Location here. That point. This is the coordinate, like your x and y coordinates here, okay? Right, so you have like kind of an x coordinate and a y coordinate from beginning algebra. And more importantly, the blue line called altangent. Let's ask you guys this question, okay? This blue line, what kind of line is that? Well, yeah, good. It's a straight line, but what I'm really looking for is the idea that this altangent that we have here is a linear equation, okay? Now, if you guys remember something about linear equations here, right? Go back to beginning algebra. I'm going to do it this way, altangent. Y minus y1 is m times x minus x1, okay? In this model, though, this is an equation of the line, generally speaking. But because I called it altangent, that means here, this is really the blue line you're looking at. However, you do want to know that this is m tangent. So the points over here are going to be this. Right, this is A, and this is what? F of A. All right, you go say, what do you mean? If you give me 1 point, and they did, if you give me a point on the line, I can give you the equation of it if I know the slope of that line. Okay, and so they're going to this portion is going to be given to you. But the slope of the line is not going to be given to you. So we're going to have to find L tangent. Now the good news is L tangent, or M tangent here, this is the slope, if you guys remember that. The good news is we know how to find that. You say, what do you mean? Well, M tangent, ladies and gentlemen, is the derivative of the function at A. So this is the reason we've been finding derivatives in some ways, because it tells us how to find that very important slope of the line tangent to the curve at the location A, FA. Okay? So, and notation-wise, this is also f of x. Evaluate x is A. Okay? So, ladies and gentlemen, this is the same exact notation. So that's the good news. So if you've been working on derivatives, and I hope you have, because we're going to start to focus really on how to apply these derivatives, you know, that's what we're doing now. And I'm giving you some homework out of the book because there's some questions regarding this. So, all right, let me see if I can dig out some examples of what I'm talking about. All right, so we're going to find the slope of the line tangent to the curve at a location. So, for example, they give you a nice curve, the square root of x over x plus 1. And they give you a point, 4 comma, I guess that's 0.4 they give it to us as? Okay. And they're going to want to know the following. What is the equation of the line, okay, tangent to the curve at P, where this is your point P? Okay? So it's going to, this is the geometry. This is the geometry in the algebra. They give you a nice curve. You want the equation of the line, tangent to the curve at the point. This is the equation they're looking for. Okay, that's from beginning algebra. Your job is going to first be to do what? To find the what? That slope of the line, tangent to the curve, which is the derivative, and I guess I have to put this here. This is what you guys want to do first, in blue. So this is your curve, though. Y equals the square root of x over x plus 1. Okay? The point they're talking about at A, they say, what do you mean at A? This is A, and then this is f of A. So your A value is 4. Okay? But the point is, what is the derivative? You're looking at everything right here. All right, you guys okay with that? Okay, see what we're trying to do? We need a derivative. Did you guys work on derivatives, I hope? Good, good, because if we need y prime, look at the notation. That's the derivative of x with respect to the square root of x over x plus 1. Okay, so what do you guys use here now? What do you guys use? Use what? Quotient rule. Good. Okay, so quotient rule is this. Okay, and double check. Is this quotient rule, I think? Okay, bring the denominator up. Sorry. Okay, now do the reverse. Square root of x. So what's the derivative of the square root of x? Do you guys remember? Good. You have that memorized? See what I'm saying? How it shows up a lot. And then what's the derivative of x plus 1? Good. Okay. So I get x plus 1 times 1 over 2 square root of x minus just the square root of x, everything over what? X plus 1 squared. Okay? Now, I could do some simplification on this here, right? You say, what do you mean? Do you guys know what I'm talking about? See that? Right? What can I do with this? I can multiply the top by 2 square root of x and the bottom by what? 2 square root of x. Okay? This is over x plus 1 squared. All right, so now I have the same denominator. Aren't I just subtracting fractions? Okay. So you now get what? Bless you. Bless you. Okay, we okay with this this algebra here? Okay. And I'm going to do this here. 2x minus x. Isn't that going to be negative x? That's going to be 1 minus x. Over 2 squared of x now times 1 over x plus 1 squared. And there's your first derivative, okay? You guys okay with that? There it is. So this is what we need to do first, right? Now, what am I saying, though? What do we need, though? What's the definition of that tangent? Right? We got this right here. We got this derivative. Okay, so we have to evaluate the derivative at what number? At a. What's a in this question here? A is what? 4. A is 4. Okay. So a is going to be 4. So ladies and gentlemen, here's what I'm saying to you. You say, okay, I'm going to put that line and put this a here has to be what number now? 4 or x. So you're going to plug in a 4 here, a 4 here, and a 4 here. M tangent is 1 minus 4 over what? 2 squared of 4. 4 plus 1 squared. Okay? Okay, so let's see. What do we get here? What's going to be that slope of the line? That's negative 3 over what? 2 times 2 times 5 squared. Is that true? Is that going to be negative 3 over what? 4 times 25. Is that right? Is that negative 3 over 100? What's this going to give you? M tangent is negative 0.0 what? 3. Is that true? So double check, ladies and gentlemen. Are we okay? Is that right? You guys double check. Did we make a mistake or everything good? Looks okay to me, right? All right, but this is just the slope of the line tangent to the curve. That's m tangent. What's the equation? Okay, let me get out my marker now. What's altangent? For that, you need y minus y1 is m tangent x minus what? x1. This is beginning algebra. This is called the equation of the line. You remember that? Where this is your one and only point right here. Okay? If you have a point, we just got m tangent. If you have that information, we can find the equation of the line. And that's going to be, geometrically speaking, this is this equation, altangent. It's a linear equation. So we do have a, we do have f of a, okay? What they gave us is right over here, right? It's 4 and what? 0.4, okay? Y minus, well, which one is y1? Do you guys know? This is the one and only point right here. This is the x1. This is the what? y1, okay? So y1 will be point what? 4, is that right? My m tangent is minus 0.03. X minus, what's the x1? Is that 4? All right. Okay, you guys okay with that? So this is what you're looking at. Although you're not done, how do we usually write these equations? You guys remember? I like to see my answers like this. Y equals mx plus what? B. This is called the slope-intercept form. Right, y is mx plus b. So what that means is I have to do a little bit of algebra, a little bit of arithmetic. Okay, we distribute. You guys okay with that? Y minus 0.4 is negative 0.03x plus, isn't that minus a minus? Isn't that 0.4 times, I'm sorry, 0.3 times 4? Do you guys know what that is? Anybody know? Is it 0.12? Double check. I'm not awake and I don't have all the coffee in me yet. Now add 0.4 to both sides. So y is going to equal negative 0.03x plus point what? I think it's 0.52. Double check, ladies and gentlemen. Okay, so double check if our arithmetic is okay. Right, you get 4 times that 0.03. Yeah, 0.12. Okay. Does that look about right to you guys? Did we do the right arithmetic? Okay, let me show you guys something in Desmos. If we still have it. There we go. Just so you guys can see it. Okay, so here's my point. We need the square root of x divided by, was that x plus 1? Because I don't remember. Is it x minus 4? Oh, thank you. Thank you. X minus 4. Now, what was that equation we just got? Y equals negative, is that 0.03 x? And then that was plus, is it 0.52? Uh-oh, something's not right. Is that, is it x plus 1? Okay, so, alrighty.
Yeah, x plus 1.
Okay, there we go. So, and I think, what was the value of A? 4? Anyway, let's change the color. I think I like to do altangent in red. Anyway, we can't really see some nice detail. You can see it, it's kissing the curve. Right, we're kissing the curve, but that line, like you said, is really what we're finding, that equation. So you guys can see that there. That's kind of what we're looking for, so you guys know. And then I'm going to give you guys another, by the way, that's a really important thing here. Okay, so this is that altangent here. So that's kind of one thing we're looking for. The equation of the line tangent to the curve at the location. And then we also want to know something about, you guys want to get used to this as well. The location of horizontal tangents. Okay? So go back to beginning algebra. What do we mean by a first of all, what do we mean by a horizontal line? Okay, so horizontal lines. What do you mean by a line that's horizontal? It looks like this. It's a line that has y. Y is a constant from beginning algebra. Is that right? Do you guys remember that? So sometimes we write it this way: y equals c. So if I say, here's my y-axis, here's my x-axis, so you guys know, okay. Here's a horizontal line, y equals c. Okay. So that's just a horizontal line. What do you guys think we mean by having a horizontal tangent, though? Yeah, there's going to be a location. If I go back to this here, I'm going to erase all this here, okay? There's going to be a location or two on your curve where the line will be horizontal. And I can see maybe like right here, on my curve. This is a location. I'll call that A. And yes, it has, this is f of A, or it could be any other letter. And there might be over here, maybe, I can't really see. My eyesight's not as good. Here's another horizontal tangent, and I don't know, maybe we call that B and f of B. It doesn't really matter. Okay, but the point I'm making is curves can have horizontal tangent lines. Okay? Now, if you have a horizontal tangent line, it's just a horizontal line through the points, kissing again at particular locations. They're kissing the curve. Okay, that's the author's language of it all, not me. That's Stuart, kissing the curve. Okay, if you read the book, you'll see that, oh, a tangent line's kissing the curve there. Sometimes that line's horizontal. What do you guys remember about horizontal lines from beginning algebra? What do you guys know about the slope of any horizontal line? Okay, if you're walking on these curves from beginning algebra, what do you guys know about the slope of those lines? Yes, m tangent equals what? 0, ladies and gentlemen. Okay. So the slope is 0. It's not a positive slope. It's not a negative slope. Slope is 0. It's called a 0 slope. Okay? So you might say, oh, wait a minute. Horizontal tangent lines happen where m tangent equals what? 0, yes. And if m tangent was defined to be that derivative at the point, right? how I see this is, you want to find where the derivative equals what? 0. Okay, so the derivative will be 0 at some location, at some a comma what? F of a. So wherever a derivative is 0, what I mean by wherever, the point where it's 0, that's the location of a what? Horizontal tangent line. So let me go back and copy this, or bring it down. So this is what we're looking for. Okay? We're looking for those locations. So if I have the original curve now, as an example, right, y equals the square root of x over x plus 1, where does this curve have a horizontal tangent? I abbreviate that HT. HT. Now, what do we get as a derivative here? Do you guys remember? We got the derivative equal to what? Was it 1 minus x over what? 2 squared of x. What else? X plus 1 squared. Is that true? Okay. Okay, so I want you guys to notice a couple of things here, though. Go back to this curve here, the original curve. What is this curve defined for, the original curve? What I'm really saying is, what's the domain of that curve? Anybody remember? Because that's going to be something we have to consider. What's your domain? X has to be greater than or equal to 0. What else? X could never be what? Well, X could be 1. It can't be negative 1. Okay, so let's go back and double check here. Okay, you say, what are we talking about? Well, the denominator, right, x plus 1, that can never be 0, which means if I solve for x, x cannot be negative 1. That's what we're also saying. But the numerator has to be strictly what? Positive or 0. So I want to just say to you guys, the domain here is really the set of all functions, or the set of all values of x, such that x is greater than 1. You say, well, why don't you throw out negative 1? Well, it is out. Because if the values of x that we can use are strictly positive, negative 1's out. Is that true?
For the square root, right?
Well, it's the square root.
Yeah, so you can't use the x.
Well, it's no. Here's what I'm saying here. Are positive, these positive numbers, it can even be 0. Okay, we know x can't be negative 1. Why didn't I list that in the domain, that x can't be negative 1? Because if x is defined only for positive numbers or 0, negative 1's out already. So, so it's already, I don't have to worry about that part. Okay, so you guys see my point? You say, what about that negative 1, Mr. Judge? Well, it's not positive. It's not 0. It's gone anyway. Well, for this, it could be negative 3. I think you only care about it if x could be a positive 3 or a positive 1. Because you're talking about the values of x for which this thing is defined, right? Because you have that square root here. What the square root says, anything you put in under the radical has to be defined. So when is the square root ever defined? Wherever that value inside is what? Positive. Or 0. So, in other words, if I look at Desmos and you say, Mr. Judge, why is it, if I can find it, that this curve, I'm going to get rid of that. That curve is only defined for values of x that are what? Greater than or equal to 0. That's why. Okay. Now, here's the real question, though. Do you have a horizontal tangent? If you do, where is it? All right. What did we just get through saying? You have a horizontal tangent wherever your first derivative equals what? 0. So here's what I mean. You have to set the first derivative now equal to what? 0. So what does that mean? We have 1 minus x over 2 squared of x, x plus 1 squared, and that equals what? 0. So I want you guys to go back. Here's something important here. If you ever have a fraction equal to 0, this is some algebra here, or arithmetic. When does a fraction ever equal 0? You say, why do I have a fraction here? Because you have what? A numerator over here. What else do you have? Denominator over here. Okay. So when does your fraction ever equal what? 0. Do you guys know? Whenever the numerator is what? 0. This is what I'm getting at. So you have to set that numerator, and what's your numerator? Equal to 0. Is that true? So we have 1 minus x equals what? 0. This is something we're going to get used to seeing here. I'm going to put that in a box, okay? So if I solve this for x, how do I do that, right? Do you guys know? How do we solve that linear equation for x? Can I add x to both sides, maybe? And then I get x equals what? Well, positive 1. What's so important about this solution? Well, that's when your derivative equals 0. In other words, ladies and gentlemen, you might say, hey, the derivative of your function happens to is 0 when x equals positive 1. Because you actually solved this equation, this fraction, you set the numerator to 0 and you found the value of x. Now, however, when they say, what's the location? What is the point? A point is 2 coordinates. It's an x coordinate and a y coordinate. You just found the x coordinate. Okay, you guys with me on that? What's the y coordinate? How do you get the y coordinate? Go back here and plug in x being 1, and what do you get for y then? Is the square root of 1 over 1 plus 1, what's that going to be? 1/2. So ladies and gentlemen, you just found the location. Very often they say, hey, what's the location? They want to know the address, P. And there's your answer, ladies and gentlemen. This is what we're looking for. The location where that derivative equals 0, it happens at the location 1 comma what? 1/2. So those two kind of important questions here.
So you just plug in 1 for the y value?
Yeah, you plug in 1 for the x value, and you get the y value. You have to go back to the original curve.
Oh, okay.
So 1 1/2, you might say, well, what does that look like? Well, take a look right here, ladies and gentlemen. Okay, let me share with you guys this if you take a closer look here, okay? At that point on the curve, you have a horizontal what? Tangent. That corresponds to the line, by the way, y equals 1 in green. Uh-oh. Sorry, y equals not 1, but what, 0.5. And let me change the color because I like these lines to be red. I want them to stand out because it's the whole point. Okay, maybe do it like that. So this is the location on the curve where you have a horizontal what? That's a big deal. We're going to be looking for those things at times. Okay, because they have a lot of applications and a lot of meaning. They have, even though right now you're looking at the geometry of a curve and saying, okay, I find that, but they have a lot of meaning. And as we find them, we'll start to discover the meaning and work with the meaning. We'll start to work with applications. But this is why you need to know how to perform a derivative so you can start working on applications. It's the whole point. Okay, what do you guys think? Goes back to a little bit of somewhat beginning algebra, that equation. A little bit of knowledge there. And there's the location. All right. Good. Okay. Let's do another one. Let's have some fun. You having fun yet? No? A little bit. You guys getting ready for Halloween? No? Good, because you're students. You're not supposed to. You're only supposed to be slaves to homework. When you're a student. When I was a student, what do you think I was? A slave to homework. I didn't celebrate anything. Not even Thanksgiving.
But you need to eat anyway.
That now you sound like my mother. That's what she would tell me. She would say, Daniel, put your books away. You got to eat. I'd say, Mom, you don't understand. I got to do this. It's not what I, and even tell that to my daughter, Ashley. It's not what you want to do. It's what you have to do. If I did what I wanted to do, jeez. You kidding me? If I did what I want to do, oh, forget about it. I do what I have to do, not what I want to do. So that's kind of how it works, ladies and gentlemen. I hate to say it. So as students, all those things you guys don't what? Worry about. Like Halloween. You say, I don't have a Halloween costume anyway. Good.
Are you going to tell us a scary story again?
Yes, I'm going to tell you a nice scary story when Halloween comes around. We even change the colors of our, of this. And I'll turn off the lights even. Tell you a nice scary story. It's crazy. But in statistics, I get to work with all these little things. I get to talk to them about, do you believe in Bigfoot? Do you believe in ghosts? Let's gather some data. Those kind of things you get to talk about in statistics. In calculus, I hate to say it. You find derivatives, you do some algebra and some arithmetic, and yeah, it's not, well, it is fun, but it's a different kind of fun. Nobody's going to celebrate Halloween? No? You don't have your costume yet? Last year's costume? What were you last year?
No, I'm just saying. I was a nurse like 5 years ago.
You were a nurse 5 years ago. Yeah, I never studied. I never celebrated anything. Now I get to celebrate.
You have your costume?
Yes. Yes, I do. I can't tell you unless you tell me what you're going to be.
I just told you.
Oh, you said you're a nurse.
I think I might be Daphne from Scooby-Doo this year.
Oh, you might be Daphne? It's pretty popular. Do you have the hair and everything?
Hair check. I ordered my costume yesterday.
I ordered a couple of costumes. I'm kind of embarrassed to say. All right.
But you just said you didn't celebrate anything.
When I was a student, I'm no longer a student. I get to now have a good time and celebrate.
You did the work.
I did the homework. I did my homework. I earned it. That's my point. I earned my celebration, ladies and gentlemen. I'm still working like crazy, though, but at least I get to do a little something every now and then. All right, I'll tell you what I'm going to be. I'm going to be Bruno.
Bruno Mars?
Not Bruno Mars. No.
From the movie?
Bruno from that Disney movie.
Oh, Encanto.
Yes. I'm Bruno.
I heard we're not supposed to talk about him.
Yes, you're not supposed to talk about him, but I'm going to be Bruno.
You've never seen Encanto, huh? We don't talk about Bruno.
You never seen that movie?
Never seen it.
It's not too bad.
Get on him.
I'm going to be Bruno.
Bruno doesn't know about the Bruno's the like most powerful one. Yeah. I need to see it because I know, but I
Do your homework and earn the hour and a half to watch Encanto, or whatever that is. But I'll be Bruno.
on a break.
Yep, I'll be Bruno.
Is it like is your family gonna be like other members? Oh, that's so cute.
Yeah, I have a 3-year-old, and so she loves that.
Is she gonna be the Mirabel?
I don't know. Yeah, I think so. That's what she's going to be. I'm going to be Bruno. I'll show you a picture. I used to actually have years ago. I used to have Halloween parties in the classroom.
Why did you stop?
Why did I stop?
Yeah, why did you stop?
Shit, I don't know if I can say. You got to be careful because when you talk about costumes, sometimes people wear costumes. Well, this is like 10 years ago, maybe. And sometimes people would wear costumes that are pretty what? Risque is the word. So there's nothing really wrong with risqueness. But if you're walking around campus in a risque costume and somebody says, "Where are you going?" They say, "I'm going to Mr. Judge's room." It's not, there's a lot of explaining to do. So I just didn't want to go through any explaining to the world. I just didn't. I said, you know what? I'm better off not having to explain this. That's it. Exactly. So it's that simple. It's like, I'm too old to have problems. That's it. Nothing more. Don't want any problems.
Maybe we could do like a potluck. That's different.
Oh, it only works for small classes. I've done that too. You have a large class, and I've done that too for Christmas time. But anyway, yeah, all the other classes you guys get to have fun. This one, work. What? Work. I have to say something about this though. To get the derivative, you really don't have enough knowledge to do it. Not in the way I'm describing.
This one requires you to use chain rule.
Well, no. That's my point. You don't know chain rule yet.
Yeah, exactly.
So you have to use some algebra. You got to use some what? Foil.
Foil.
Now you can find the derivative. In the future, yes, there would be a little bit easier way to do this. So now m tangent is going to be what? Y prime. Let's take the derivative here. Do you guys know the derivative of this? What's this derivative? Isn't that going to be, you go through every detail. What's this going to be? 0. What's this? 4. What's this? 8x. So m tangent, or you can just say along the way y prime. Okay. 4 plus what? 8x. Okay, so this is the slope of the line tangent to the curve. So this is the first thing you have to find. Now, the second thing you have to find is, oh, what? They want to know when, what's the value of A here? This is the location here. This is, you can call that A if you like, or X. It doesn't matter. Right? A, X, M tangent. So this, I have to evaluate when x equals 1. So m tangent becomes 4 plus 8 times 1. What does that give you? 4 plus 8, isn't that 12? All right. So you guys see the reason why you had to do all your derivatives? Because now you're starting to use them. Now this is just the slope of the line tangent to the curve. How do you get the equation of the line tangent? This is our what? Tangent. Y minus y1 is m tangent x minus what? x1. But don't we need a point? Yes. So you have a point. So plug those values in. This is the x coordinate. Plug it in. Bless you. Maybe I got to change some colors here because it might be easier to see that way. Because make sure you put the coordinates in the right locations, right? So now you're going to have a what? Y here. Minus 9 becomes 12. And x minus 1. So don't forget to do that little bit of algebra and arithmetic to get this in slope-intercept form. So we get y is 12x minus what? 3. So here we go, ladies and gentlemen. Easy peasy, lemon, what? Squeezy. Okay, you guys okay with that? Now, let me give you guys a note here. Let's note. How do you find the horizontal tangents? Yeah, you're going to have to set the derivative. Where's the derivative? See this derivative? You already got it. Set it equal to what? 0. Okay. 4 plus 8x equals 0. So now you have to solve for x because we need the location where it equals 0. So, all right, subtract 4. And it looks like we get what? 8x is divide both sides by 8. What do you get for x? X is negative 1/2. Okay, now remember, this is only what? The x coordinate. How do you get the y coordinate? You got to go back here.
Plugging into
The original, because it's an xy coordinate on the curve. So they want that location here. So for the location, you say, okay, plug in negative 0.5 here, or negative 1/2 for x. So you say y now will be 1 plus 2 times negative 1/2. We're going to square that. Isn't that 1 minus 1, I think? And that 0 squared will be 0. Okay, so what's the location here going to be?
0.
It's negative 1/2, comma what? 0. I got to get the colors. All right, negative 1/2, comma 0. So, you know, if I went back to the original curve in decimals, right? If you said to me, can we see that? y equals parentheses, I think was that 1 plus 2x squared? Was that the curve? I think so. Ah. It's a nice parabola. Do you guys see that down there? Okay, so at negative 1/2, 0, you have a horizontal tangent. So that's actually, if I now go back up here to this curve, just put a negative sign. Okay, let's put a negative sign. Oh, I'm sorry, I think it's 0. It's going to be the y coordinate value. There we go. You can actually see it there. So in purple is the original curve. It's a parabola. The equation of the line tangent to the curve at that point would be y is negative, well, it's actually y is 0. And there you go. So ladies and gentlemen, there's a picture of a curve with a horizontal tangent. Now, what was the equation of the line here for the original? 12x minus 3 happens at 1, 9, right? So 12x minus 3, if I go to decimals for that, I think I need the x is 9. Ah. Yeah. Well, let's see. No, where was that location? X is 1, y is 9. Okay. X is 1, y is 9. So the original question, that's the equation of the line tangent to the curve at 1, 9. That's, what's that? Thank you. 12x minus 3. Okay. So here it is, 1, 9. Okay, so there it's kissing the curve at 1, 9. So the original question, the first question, what's the equation of the line tangent to the curve at 1, 9? It's 12x minus 3. And that was the original question. And then we found the horizontal tangent, ladies and gentlemen, and it happens at negative 1/2, 0, right in there. Yes? Oh, that's a very good question. How do we know if there's more than one? Because the equation that you solve here, let me find it. So far, the equation that we solved here, this y prime is linear. Okay, so you have a what's called a linear, this is linear equation. So when you set that equal to 0, there's only one solution. So if it's quadratic, there'll be 2 solutions. If it's cubic, there'll be 3, and so on. So we're actually just kind of easing your way into some of these things.
So for the,
Yeah.
like, how to determine, like, the graph has, like, different, I mean, like, horizontal tangent line is to check the power, right?
Well, it's going to be whatever equation you have to solve will tell you how many solutions. Like, for example, like here's kind of one. Okay, so let's take a look at this example. And you want to find your horizontal tangents. Say, oh, we got horizontal tangents. Determine what? My prime. So kind of like, this is like a homework question. Okay, so I'm going to put HT. So I'm going to take the fun away from you for this one, okay? And you might say, how do I get that derivative? Well, use your power rule here for these. Right? You did that homework for a reason. Derivative of x cubed will be what? 3x squared. What's the derivative of x squared? 2x, the derivative of x. 1, derivative of 1. Okay. So now you get y prime going to be 3x squared minus 2x minus 1. Okay. All right, ladies and gentlemen. The question is, determine the location of your horizontal tangents, right? You say, I already know. Set y prime equal to what? 0. So that means if y prime is 0, you guys know what that means? We have to say what? 3x squared minus 2x minus 1 equals what? 0. And then you got to solve for what? X. Okay, now let me say this to you guys. Maybe it's a good time to share with you guys some resources. 0.5464. Okay. So, what do you guys remember? What do you think you have to do? Yeah, you guys have to factor that, right? You have to factor and use the zero product rule. So, this is A, B, C. Okay? All right. Do you guys remember this crisscross method? Yes, you have to do what? We need AB. No, we need AC. You say, what is AC? Well, A is 3. Yeah, it's going to be 3 times negative 1, which would be negative 3. Is that right? And then this is B, which is negative 2. So remember, we need two numbers whose product is negative 3, whose sum is negative 2. This is the crisscross method. Two numbers whose product is negative 3 and whose sum is negative 2. What's it going to be? Let's double check. Does that work? Is negative 3 times 1 negative 3? Right? Okay. So the product is fine. Is negative 3 plus 1 negative 2? Ladies and gentlemen, those are the numbers. Okay? So yes, that works. So let me go through the details of this crisscross method, okay? So we put x here minus 3. We put x here plus 1. Is that true? But be careful here. You say, what do you mean? You see that number here? There's a leading coefficient here. A is 3. You would be done if A is 1. So because A is 3, that number, whatever that number is, we're going to divide these numbers by A. A happens to be 3. So this is the crisscross method of factoring. All right. Now, what's nice about the first quotient problem is that 3 divided by 3 is what? 1. What's the problem with 1 divided by 3? It's not, yeah, it's not a nice whole number integer, really. So because of that, you guys remember what you do? You move it up to the x. This is the crisscross method for what? For factoring, ladies and gentlemen. So that's answering Elizabeth's question that there's a quadratic to solve. There's going to be two values. Sorry. Now what do you guys use?
Send them both to
The zero what? Product rule. So you say, what's that zero product rule? If A times B equals 0, then what does that mean? What does that mean? Then A is 0 or what? B is 0. Okay? This is from beginning algebra. Okay, this is how you solve the quadratic from beginning algebra. Do you guys remember that stuff? This is a very famous zero product rule. So I didn't learn algebra until I took what? Calculus. I didn't learn arithmetic until I took what? Calculus. X minus 1 is 0. 3x plus 1 is 0. Jeez. This is my A minus 1, and this is the what? B. So solve these for x, right? So this will be adding 1 to both sides. You get x is 1, and here you have to do more than that. This will be 3x. Negative 1 divided by 3. X is negative 1/3. X is 1. X is negative 1/3. So, ladies and gentlemen, you're going to have to plug these numbers back into where? Here. So, to get the corresponding y coordinate values. Okay, because they want locations. They want points. So, if I plug in 1, plugging in 1 is nice because you now get y being 1 cubed minus 1 squared minus 1 plus 1. So we get 1 minus 1 minus 1 plus 1. I think that's 0. Is that true? Yeah, that's 0. So the first location would be x is 1, y is 0. This one has 2 locations. Now, the second location is a little bit more difficult because you got to plug in negative 1/3 here. Oops. Okay, so let's do some of this arithmetic. Y is negative 1/3 cubed minus negative 1/3 squared minus a negative 1/3 plus 1. So y is negative 1/27 minus 1/9 plus 1/3 plus 1. Do you guys know what the LCM is? So multiply this by 3. 9. This is 27/27. Is that right? So we get negative 1/27 minus 3/27 plus 9/27 plus 27/27. So what do you get now? Over 27. Negative 1 minus 3. Is that negative 4 plus 9? Is that 5? 5 plus 27 will be? Is that 32? So, ladies and gentlemen, I think this is negative 1/3, comma, 32 over 27. Here is the second location. So this problem has what? Two locations. And if I look at this curve in Desmos, y is what? X cubed minus x squared minus x plus 1. Take a look. You see this location here at 1 and what? Negative 1/3. Let me ask you guys a question because this is a big deal. If you were walking, if you're going hiking, what do you guys notice about those special locations? You're at the top of the hill, and then where are you at? The valley. Is that true? That's going to have meaning for us in our future. We're going to be trying to find the hills and location of where you're on the top of the hill and when you're in the valley. So this is why we care about what? Finding derivatives and solving these equations. So this is, now there's two horizontal tangents, by the way. It's a big deal. It's a good question. We're out of time, and I was just kind of looking on my website trying to find if I had anything on horizontal tangents. I have some other stuff, but I did one that's on your homework. Tomorrow we're going to look at some trigonometry curves, since you guys know how to take derivatives for trig curves, and try to find some of the same things. All right, take care, stay safe, have a wonderful day. We'll see you guys tomorrow. Ladies and gentlemen, let's double check to make sure our volume is on. It looks like it is. Okay, so what I want to do here is remind you our lectures are online, and I also want to say to you, I put up what I'm going to go through soon is a video on solving quadratics by what? Factoring, a kind of review of really the factoring technique of the crisscross method. Remember I promised I'd do a review of that for people in case they forgot how to factor, because that's going to come up, and I'll give you that information there, factoring by the crisscross method, but also how to solve the equations by using the zero product rule. So this is really, in essence, solving quadratics. You know, but it's really actually Math 115, beginning algebra. If you guys didn't know.
What's the lowest, like, math? I mean, course.
The lowest math course?
Yeah, like, in terms of, like, hardness.
In terms of what?
Like, hardness?
Hardness?
Yeah. Which one is, like, more basic?
Well, the lowest one here at the moment is probably 241 or 230, but it used to be arithmetic. Okay, so all these courses we used to cover this topic here. But what I'm saying is I'll make a video for you on the crisscross method, factoring, and also combining how to solve using the zero product rule, because it's really done together, in all honesty, in a calculus course. So I'll get that up for you guys. Okay, Shannon? I did do the what? I did do this, whatever this was, and I was going to do the video yesterday, but there were people working at home on the water lines right outside and had all this noise. They're like, oh, really? So, no audio. So anyway, there it is. So, it's coming, and, you know, like I said, we'll get that up for you guys. Okay. And I'll send it to you via an announcement in Canvas.
Where can we find the video that you are going to make?
I will send it as an announcement in Canvas. Okay, so ladies and gentlemen, let's continue with determine the what? The equation of the line tangent to the curve. And it's going to be at the location P, okay? However, you might say, what if they give you y equals 1 plus x sine x, this is the equation, and then the point's going to be at the origin, for example. All right, let's see. Shall we do that? How about if I do this? Let me change that. No, we could keep it that way. Okay, so I'm going to try something here. If we go to Desmos. There we go. And I don't like to use that color, so okay. All right. So we're going to try to find the equation of the line tangent to the curve at this particular location here. At 0, 0. At the origin. All right? Okay. So just to kind of throw that out there, how to do that. To remind you guys that this can be done with what? With trig functions as well. So in order to do that, remember we need the slope. We need m tangent. And that is the derivative of the function, y prime, evaluated when x is what? 0. Right there for this value here. Okay, so I need the derivative. So, okay. So y prime will be here we go. So you're going to have to use what again? Product rule, is that right? What's the derivative of sine? Cosine. What's the derivative of 1 plus x? 1. Is that right? So you're going to get what? 1 plus x times what? Cosine plus what? Sine. So here's my derivative. So in order to use this definition here of m tangent, we got to do what now? Got to plug in x equal to what? 0. Okay, so we got to plug in 0 here wherever there's an x. Now, what do you get now? That's really m tangent. So m tangent will be 1 plus 0. Cosine 0 plus what? Sine 0. So we do have to know what these things are. Cosine 0 is 1. What's sine 0? 0. Okay, so in this case, m tangent is 1 plus what? 0 times 1, and I think it's safe to say m tangent would be what? 1. Okay? So double check, ladies and gentlemen, my arithmetic, okay? Double check and see if that's correct.
Yeah, you are correct.
So that's the first part, okay? They want the what? The equation of the what? Line tangent to the curve at the location P. So what's this equation going to be? You guys remember? What's this? Y minus y1 is m tangent x minus what? x1. Okay? Now, so the location 0, 0, that point, right? I'm going to use some colors here. This is going to be over here. Okay? This is your x1 and this is your y1. So you got x1, you have what? y1, right? And they're both 0. Okay, so not as interesting, I guess. There's y1 and here's what? x1. They're both 0. So you get y minus 0 is 1 times what? X minus 0, which means y is really what? X. And we call this L what? L tangent. So when I put this in Desmos, if I just kind of compare here, ladies and gentlemen, here's my point to you. That's the equation of the line tangent to the curve at the location 0, 0. Okay, so we're barely kissing that curve there through that point. That's called the tangent line. All right, you guys okay with that? All right, so here's the deal, though. Here's the deal. I just want to kind of go back a little bit because there's another definition I want to give you guys. And you say, what do you mean? Well, definition of the normal line to a curve at P. So you got some point, X and Y, okay? The normal line. The normal line, I'll put L with maybe an N, is perpendicular to the what? Tangent line at P. So you might want to say, and it's really not the definition, and it's just kind of sketching what it is. Let me, if I can write a definition down, though, in words, if you guys wanted one. So definition, one can say something like, oh, normal line to a curve F at P is the following. The line Ln that is perpendicular to the tangent line at the location here. Okay? So here we go. Now it's easy peasy. You say, what do you mean easy peasy? You guys remember this is a symbol for what? Perpendicular. And this shows up in science, this normal line. And in order to find that, you know what you guys have to do again? You got to go back to what? Beginning algebra. The course they say nobody really needs, right? So do you guys remember, what's the relationship between lines that are perpendicular? Let me go back. Yeah, here's the deal. Let me write this down. Let me say this. L1 is perpendicular to L2. Okay? What do you guys remember about perpendicular lines? I'm going to draw a line. L1. There's another line. L2. You guys want to know something? These lines are what? Perpendicular at this location P. Okay, it has an X and Y coordinate. So let's go back to beginning algebra. Okay? Perpendicular lines, what do you guys remember? What do you guys know? The product of the slopes, M1 times n2. M2 would be negative 1. Where M1 is a slope for line 1 and M2 is a slope for line 2. So you have this relationship whenever you have what's called perpendicular lines. That symbol is perpendicular. Okay, now what that really means is that M1 and M2, so if you have a slope, you know, this is what it means. M1 and M2 are opposite in sign and are reciprocals. So you're opposite and reciprocal. Okay, because if you solved for M1, you're minus 1 over M2. Okay, so this is kind of what that means. You're opposite in sign, reciprocal in value. So that's the deal. So if I asked you guys, hey, okay, go back to this original function we looked at to find the equation of the line tangent to the curve. We got the derivative. I'm now going to ask you, hey, what is the normal line at the origin? So what's the normal line at that location? Okay, so you might say, well, what did you get? What was M tangent, ladies and gentlemen?
Y equals to N.
Do you guys remember the value for M tangent at that location? It's positive 1. Is that true? Okay, so what's the slope of the normal line at that location? Has to be opposite in sign, reciprocal in value. So you might say, okay, can I put that as 1 over 1 so I could get a reciprocal? Yes. So then that makes it minus, flip 1 over 1 over. Don't you get 1 over 1? So here's my point. The slope of the normal line is actually what? Negative 1. As the slope of your tangent line, we found earlier, was what? Positive 1. So they want the equation of the normal line now at 0, 0. So you go, okay, what does that look like? Well, use the same beginning algebra. Y minus what? Y1 is m times x minus x1, where yet again, x1, y1, let's colorize these things, and then your slope's going to be negative 1. That one down here is going to be that negative 1 value. So now, ladies and gentlemen, you get now what? Plug in those values. 0, 0. What do you get? Y minus 0 becomes negative 1 times x minus 0. Or we say y is just negative what? X. This is our normal now. So you even have what's known as a normal line. And so, ladies and gentlemen, we're going to see in Desmos what that looks like. Okay, so y is now negative x, normal line. And I'm going to paint this purple, just like the notes. Okay, so if you look at this here, and again, it shows up in science. So the reason we do this is because it shows up in your science courses. So at the origin, ladies and gentlemen, you got the tangent line, and you have what's called a what? Normal line, a line perpendicular to the tangent line.
We have a question.
Yeah.
So the normal line basically means a line perpendicular to the original line.
Perpendicular to the tangent line
Oh, okay.
at a point.
That's the definition of like normal.
Yeah, the definition, it's really the definition of a normal line at a point and a tangent line at a point. So the normal line at a point is just a line that's perpendicular also known as being orthogonal to the tangent line at the point. And to know what that really means is you go back to beginning algebra when are lines perpendicular? Well, when the slopes are opposite in sign and reciprocal in value. So if the tangent line, let's say, had a slope of 1/4, the normal line will have a slope of -4. If the tangent line had a slope of -2/3, the normal line will have a slope of what? Positive 3/2. So it's opposite in sign and reciprocal. That's all. And as you guys can see a nice picture, there it is. There's the picture of it all. And that all is from this situation, that curve. And then you might say, hey, Mr. Judge, are there any horizontal tangents on this? I'll say, actually, there's quite a few. There's one here. So you say, what do you mean? Horizontal tangents or when you're at top of a hill or a valley. So if I take out this other stuff that we have, are you on top of a hill here? Yes. Are you in a valley here? Yes. Are you in a hill here? You're in a valley? You're in a hill? You're in a valley? Let's valley, hill, valley. Has tons of what? Locations of horizontal tangents. But be very careful. So let's go back to yesterday. When do you guys have a horizontal tangent? It's the values or the points on a curve where the slope of your tangent line is 0. Y prime equals 0. So be careful, ladies and gentlemen, because I'm not going to ask you for this question here. I'm trying to find the derivative. See this derivative? Here's a derivative. I'm not going to ask you for this function. Where's the horizontal tangents? Do you guys know why? Oh, I guess I could. Can I? No, I can't. Can I? No, I can't. Can't do it. You guys know why?
It's continuous and aspect.
No. You say, Mr. Judge, why is it for this? What's the derivative? See, here's the thing about it. Should say generally speaking. Okay. If I had to set that derivative equal to 0 and solve for x, you actually can't do it. So a lot of these questions are very specially chosen. You would have to, it can be done in Calculus 1, but we're not there yet. You see, Calculus 1, the application of a derivative, there's a lot of different applications of it. We're just trying to find and begin our adventure in the applications. But this question, as it stands now, you can't really solve for y prime equal to 0. You know, you can't let it be 0 and solve for x. It can be done with future tools, but we're not there yet. They can still ask you the question, but they're going to give you a different function. You say, really? Yeah. They're going to say, determine location of what? Determine the points for HT. What do you mean by HT? Do you guys know? Horizontal tangents, where the derivative equals 0 at a particular location. So, I mean, there's a few in your book, and I don't really want find an equation of lines. Do they? Yeah. For what values of x does the graph have a horizontal tangent? Okay. So I'm going to do this. I'm going to change it. Okay. I'm going to say determine the points in the curve where you have a horizontal tangent, and then I'm going to restrict the domain over the values of x between 0 and what? 2 pi. Okay? Now, this is x plus 2 cosine x. So they want locations where you have a what? Horizontal tangent. Okay. So when you see this, you know what you think of? Set the derivative equal to 0. Solve for what? X. Okay, so now what's the derivative of this function, right? Y prime is going to be what? D dx, x plus what? 2 cosine. And what's that going to give you? Properties of derivatives, okay? I use operator notation. I think that's the best notation ever. And we can still see the nice properties. So what's the derivative of x? What's the derivative of cosine? Minus sine. So y prime becomes what? 1 plus what? 2 times minus sine, okay? So we get 1 minus 2, what? Sine. You guys okay with this? Good. What do you think? There you guys go.
Would it be wrong if we put, if we kept the 2 with the cosine and the derivative?
Say that again.
Would it be wrong if, so after the derivative, the d over dx, or the cosine, if we leave it with the 2? So you know how you put.
You mean if you took the derivative, I think what I understand, if you took the derivative here?
Yeah.
Well, no, if so long as you have negative 2 sine x as the derivative. But I'm giving every detail because that, for me, and even like I said, when I helped my daughter with her homework in calculus, I said, hey, use these operator notation, go through these steps the same way. What happens is if you start skipping some steps, then you might make a mistake personally. So that's why I always encourage to use the proper properties, because you're really training yourself to get answers, in all honesty. I can do this course in my sleep. You guys don't even know. I'm actually asleep right now. And you go, well, how could you do that? Because, why? You go through the steps every single time. It's kind of like Magic Johnson making free throws. He could probably do it in his sleep. Why? Because every morning he practiced 100 free throws. See, ladies and gentlemen, this is all about what? Developing your skill sets. And if you don't do that, then you'll have a problem. That's why you can't study the night before or the weekend before and do this and think it's going to work out. It's just, it won't ever work out. It's like saying, I got to write a song and I do it the night before. Oh, no, here's a better analogy. I used to have to watch this show, Say Yes to the Dress, with my daughter. And they would always give the bride's advice: don't get a wedding dress smaller than you are now. And the brides would they go, no. I'm going to get 3 sizes smaller because I'm going to fit that dress. This will pressure me into diet and losing weight if I do it that way. And they'd still tell them, don't do it. They wouldn't listen. And what would happen is the night before, they would show the brides in tears. And I was watching that with my daughter, and I would laugh. It was funny. And you go, Mr. Judge, that's so mean. It's not so mean. It's funny. Why? Could you lose weight the night before your wedding to get in your dress?
Probably not.
You guys see my point? You guys see what I mean? So you want to do the work when?
Yes, sir.
Yesterday. If you don't, what happens? You're going to be crying like saying yes to the dress. Do you guys see what I'm saying? So it's kind of an interesting thing. So, yeah, I mean, I showed my daughter this and I say, oh, look at that. This is how you want to do this. And she was like, oh, okay. I can see the operative notation and all the properties. Oh, okay. And then I'd say, I just tell her this. You know what, Ashley? You got to find the horizontal tangent. Here's what you do. Set the first derivative equal to 0, solve for x. That's it. Now go clean your room. You guys know what I mean? Set the first derivative equal to 0, solve for x. That's it. Next question. So here's what you do. You set this what? 1 minus 2 what? Sine x equal to what? 0, and then you solve for x. Now here's another thing to remind people of. What are you guys looking at, ladies and gentlemen? What is this known as? Oh, shoot. A trig equation. See, I thought I didn't have to take trig. Somebody lied to you. Because here's a trig what? Equation. You guys know what I mean? Has anybody, you guys remember trig? It's another class they say nobody needs. It's like, really? All right. They just say, send the students to tutoring and then they can learn how to solve an equation. Okay. Okay. Go ahead. However, ladies and gentlemen, do I have any resources for you guys? Remember, I have some resources, and they're free. Because in the future, those publishing companies, they're going to charge you a lot of money for these resources. That's what this is about. But I'm going to leave my resources up for free. What class is it? Oh, no, sorry, wrong class. Let's go to trig. So, ladies and gentlemen, I got trig, libraries of resources. I'm still doing a lot of trig resources. So, there's trig equations here for you guys, okay? All right. Oh, there we go. Solving trig equations. Look at all this. I would say go right here. Single angle trig equations here. Okay. Well, oh, this is no algebra. Sorry. You got to go here, trig equations where there's algebra. And there you go. Let's put it there. Okay, so if you forgot how to do that, I recommend you guys take a look. In fact, I actually covered some of this stuff, not solving trig equations, but I covered this topic earlier today, how to do some of these things, but in trig. So, you know, I'll be putting up more trig resources there. But, all right, do you guys remember how to do this? How do you guys do that? All right, remember, I'm going to translate. I'm going to move that 2 sine x to the other side. This is 2 sine x equals 1. Now, what do you guys do? Alberto, yes, I did. Alberto has a question. Do we have a trig worksheet? Yes. Yes, I did. It's in 261. If I can get to 261. Okay, your trig worksheet is there. Oh, and by the way, in the future, they're going to probably remove pre-calculus and trigonometry.
For what reason?
You don't need it to take calculus. It's probably in about a year. So here you go. Here you go. This is the stuff we did already. Alberto. Okay, so I'm going to go back over here. All right, so it's right here, Alberto. I don't think it's right here. It's called trig derivatives. And then you have the video over here. Okay, so there we go. Okay, so ladies and gentlemen, there you go here. All right, now divide both sides by 2. Do you guys remember that? And what do you get? Sine x equals 1/2. Okay. The question is going to be, what is x? The question is, what is x? Do you remember how to do that? Okay. So how do you guys do that? What's the definition of sine? Do you guys remember? Because what's going to happen is this. What's the definition of sine? Isn't this what? Opposite over what? Hypotenuse. You guys remember that? So you're going to draw a triangle here. You have your angle x. What's the opposite side? 1. What's the hypotenuse? 2. So the question is, what special triangle is this? There's only 2. There's only 2 special triangles. Do you guys remember that? That's the kind of interesting thing about this. If you don't know what that is, find this side down here, right? You find this adjacent side. You know what you're going to find? The adjacent side by the Pythagorean theorem, if you guys remember that, square root of 3. So, what angle is that? What special triangle is that? You guys know? I can see it this way. And that 1 and that's 2. So, what is it, x? Sorry, I should probably draw straighter lines. Do you guys know? Here's 1, here's 2. What is x going to be? Isn't that 30 degrees? You guys remember that? Special triangle? Yep, 30 degrees. And you need this in radians, by the way. So what is 30 degrees in radians? Pi over what? 6. Okay. However, this is only a quadrant 1 angle. So this is quadrant what? 1. You guys okay with that? There's another quadrant where sine is positive. You say, how do I know? Well, all students take what? Calculus. All students take calculus, ladies and gentlemen. Okay. So x is pi over 6, quadrant 1. What other quadrant? And pi over 6 we said was what, 30 degrees? All right. So what other quadrant, ladies and gentlemen, is what? Is sine positive 1/2? Do you guys want to know? It's quadrant what? What does this all students take calculus mean? Yeah, doesn't let me do that. Okay, come on. Also, that means it's quadrant. It's in quadrant what? 1 and quadrant what? 2. But what angle is it? Right. If this is 30 degrees. Okay, you got 30 degrees here. Then you guys know what else is going on? This is also what? 30 degrees. But what what angle is that going to be? This picture, it's 150. I guess we should draw another. Let's get rid of this. Okay, we'll draw another ray. Okay. $30 degrees. Yes. I'm sorry. Say it again.
What happened to the negative from the equation? Because isn't it 1 minus 2?
Yeah. Well, when I added 2 sine x or move it to the other side, that 2 became positive because it's now on the other side. And you divide both sides by 2, so it's sine being equal to a positive 1/2. And sine is positive in quadrant 1, quadrant what? Quadrant 2. But what's the angle? You might say, I don't know what that is. Well, quadrant 2, if you guys remember, okay, what's the relationship? X will be what? Pi minus the reference angle of pi over 3, I believe. Is that right? Pi over 6. Okay, this is the reference angle, pi over 6. So there you guys go. Okay, so now you have what? 6 over what? 6. So what's that going to give you? 5 pi over what? 6. So your two solutions, ladies and gentlemen, is pi over 6 and what? 5 pi over 6. So I just want to give you all the gory detail here. Yes, there's some trig, ladies and gentlemen. There's a trig equation. You have trig functions. Okay? Now, this is in the restricted domain for what? 0 to what? 2 pi. Okay, you guys okay with that? So you said, wow, okay, that's between 0 and 2 pi. Let me give you guys a note or a by the way. What if there is no restriction in your domain? What did you guys have to do in trig? Right? If there's no restriction in the domain, your first solution was pi over 6. And the second solution was what? 5 pi over 6. Okay? What if they didn't give you any restriction? You go, what do you mean? What if they remove the restriction? What if this was not here? You go, oh, they gave it to me in general. No restriction. X plus cosine. What do you guys have to do? Yeah, you add multiples of what? 2n pi? For both. What is n? N is an integer. So this is called, if there's no restriction, this is your general solution. Okay, so you even have general solution here. So there is some trig there, ladies and gentlemen. General solution here. Anyway, so let's go back in pi over 6 and 5. So then you said, but they asked me for points, and points on your curve is what? Isn't that an x coordinate and a y coordinate? Is that true? X plus 2 cosine x. So you might say, how do I get my y coordinate values? Okay, what's your first solution? Isn't x pi over 6? So guess what? Plug in what? Pi over 6, plug in what? Pi over 6. Let's see, what's the corresponding y value? Won't it be pi over 6 plus what? 2 cosine what? What's pi over 6 anyway? 30 degrees? Okay. So what is, ladies and gentlemen, cosine of 30 degrees? Do you guys know what that is? Cosine 30? I think I got to go back to my triangle. This is 30, right? So what's cosine going to be if that's 30 degrees, right? Cosine is going to be what? Adjacent over hypotenuse, square root of 3 over 2. So what happens to your y? Isn't that going to be what? Pi over 6 plus square root of 3. So here you go. Here's the x. Here's the y. That's what they mean by the first point. Pi over 6. What's the y value? Pi over 6 plus the square root of 3. Okay, so there's your first address here for location. What about if they said the second x coordinate was 5 pi over 6? Now that gives you y equals, plug in what now? Your 5 pi over 6, okay? So you get what? So I need to know what cosine 5 pi over 6 is. That's the kind of stuff we covered today in trig. So what I taught today in trig is 5 pi over 6. What is that? 30 degrees again? So what's 5 times 30? Okay, so here's a multiple. 5 times 30 becomes, is that 150 degrees? Okay. So what's cosine 150? Do you guys know what cosine 150 is? You know what you have to do? You have to go back and remember, all students take what? Calculus. This is what I did for the trig students. Cosine 150. So that ray, right, we rotate. Ah, what do I know? What's the reference angle? Yep.
You just do the same thing.
It's the reference angle, and what do you guys know? Cosine 150, just to let you guys know. Since all students take calculus, the 150 degree angle is in quadrant what? 2. What does that mean?
Negative.
Yeah, it means sine's positive. That's what the S stands for, but cosine's negative. So that'll be negative cosine of what? 30. Did you know what cosine 130 is again? What's cosine 30? You already answered that. It's what? Yeah, you answered it right in here. Square root of 3 over 2.
Same also for all.
But it's going to be negative, though. So that's going to be a negative square root of 3 over 2. So this goes where? Here. That's negative square root of 3 over 2. So what does that mean? Your 2's cancel, and now what is your y going to be? It's 5 pi over 6 minus what? Square root of 3. So what's this point going to be here? There it is. Easy peasy, lemon squeezy. What is this curve? X plus 2 it's x plus 2 cosine, right? So in Desmos, you might say y equals what? X plus 2 cosine. Okay. However, the domain was restricted. You see, this is when it's any real number for your domain. You have infinitely many solutions here. Remember, you're on top of a hill. top of a hill, top of a hill. You're in valleys. These are all the solutions, ladies and gentlemen, for horizontal tangents, generally speaking. Okay, all those locations. But if they restrict the domain, there's a way. Where is it? I need the brackets. Where are your brackets? I've only been using this a million times. We need the curly brackets. Where are you, curly brackets? Let's see, restricted domain, Desmos. Yeah, I know that, but how do we get to the curly brackets here?
Try holding on the parentheses.
Huh?
Try holding on the parentheses. Like, press and hold.
Hold on the parentheses?
Yeah. No.
No, it's actually on your keyboard. You can do it on your keyboard.
Yeah. 'Cause
What?
sometimes it gives you a second option.
Yeah, you can do it on your keyboard. Don't have my keyboard. Anyway, so yeah, you can do it on your keyboard. So it's actually 0 to 6.
Go ABC.
ABC.
Yeah, the bottom left.
Oh, there we go. You're right. Thank you. I've only, like I said, I've only been doing it a million times.
Yeah, I just pulled it up on my phone and I just found it.
Yeah. Yeah, and then there's going to be 2 pi here. I think there's going to be pi somewhere. I think you spell it out. Oh, come on. Two po. Okay. So here's what you guys have found here, just so you guys know. You see these 2 solutions? Let's make it really big. Okay, you're on top of a hill and you're in a valley at what values of x? Pi over 6, and what's the other one? 5 pi over 6. That's the restricted domain from 0 to 2 pi. So, you know, if they give you a restricted domain, you should be happy. If they don't, you can still do it, but you have now the family of solutions. And I, even in the trig class, what I went over in trig is how to take a general solution. Here's your general solution, and write what's called the sequential solution. And I'll kind of show you guys that really quick here. But I do have extra videos there. I got a ton of videos. And, you know, maybe I'll put those up. I have no idea. Okay, you guys know what I mean by the sequential solution here? Okay, that's kind of a calculus kind of thing. Sequential solution is really when they say to you, write this as a sequence. Okay, so it's kind of simple. It's very simple. You see this denominator, 6? You want to multiply the top by 6, the bottom by 6. You're going to add the fraction with this whole number. But that's 12n pi now over what? 6. You guys okay with that? Factor out your pi over 6. And what do? Pi over 6, and what's this? 1 plus what? 12n. N is an integer. So this is a nice way to get all those multiples of pi over 6 as solutions for x. Another nice, you got to do with the other one. So you might even looking back at the book in some of these questions, and you said, how did they get those answers? Well, they wrote this sequentially. And that's 5 pi. Again, 12n pi over what? 6 again. And you factored out the common, factored out common pi over 6. So you now have x equal to what? Do another pi over 6. Pi over 6, 5 plus 12n. There it is. N is a what? Integer. So now you can very easily, just by using n is 0, n is 1, n is 2, because those are all your integers, right? Remember this? There's your integers. Anyway. Yeah. Well, if they don't restrict the domain, these are all your x coordinates. You, I would say I would write sequential. You're going to see, like, when you're looking back at the book, you'll see, oh, they put the sequential solution. Hold on, let's answer the question. You're looking back at the book, what will you see for your x values? The sequential solution. Right? You go, what are you talking about? These are going to be the x values. You see this formula. Pi over 6, 1 plus 12n, pi over 6, 5 plus 12n. No, you don't have to substitute. You write the formula. This is called the what? Sequential solution. So I just want you to share that with you guys, because sometimes people look at that and they go, where did they get it from, right? Where did they get the sequential solution? Now, when I teach trig, I teach the trig students to also give me the what? Sequential solution. So that when they take calculus, they go, oh yeah, there it is. That's the whole idea. You know, I even tell them, when you take a calculus course, you might see answers in what? Sequential solution like this. So that's kind of how I do it. Now, I don't know, some of you guys maybe didn't take trig. Some people took trig in high school maybe. Some people took trig with another instructor. And maybe that instructor said, hey, the general solution was fine. No idea. But I just share with you guys here the what? Sequential solution. And I might even go back and look at my videos, because I might post them somewhere on my website, if I can find space, right? Sequential solution. Because I just know from teaching calculus, not everybody gives students a sequential solution for solving a trig equation. So, I mean, that's just my personal experience, right? So, we left the trig settings, so. But yeah, I do have tons of trig, so let you guys know it's up there as well. And I have even more at home. Not at home, but I have them. I have the files. There's a lot of stuff we do in trig. Anyway, maybe Elon Musk will buy my website. But it's true, in the future, they're just going to get rid of these courses and make you pay money for accessing apps, or not my website, but some publisher kind of material. Because they said you guys all learned this in high school. Anyway, not my high school. But your high school. Okay.
So Professor?
Yeah.
When there isn't a domain present, we write in general.
General, yes. No domain? Yes. Well, I mean, there's always a domain. If they don't restrict the domain.
Yeah, I'm
Right.
about like,
And you say, how do you know when they restrict the domain? Because you'll see X is good for these values. Yes. And that, anyway.
So no domain means general solution or sequential solution.
Say that again?
So, no domain means general solution and sequential solution.
Say, it always has a domain.
I mean, no, restricted.
Restricted domain means you can write the particular solution in the restriction. If they do not restrict, they just give you, hey, do that for all values of x, then that's the general solution they're talking about. And yes, you can do and you'll see in the calculus solution book, the sequential form. Yeah, you'll see that. Anyway.
Thank you.
Yep. So yeah, determine the equation of the what? Line tangent to the curve, right? At your location P. So you say, what if they give me a...
Professor, we don't see the screen.
Yeah.
Oh, I'm sorry. I'm trying to think. It not so easy to do up here. What if they give you x sine x, right, at pi over 2, pi over 2. I think that's okay. Okay. So again, this is that L tangent situation. Okay, so how do you guys get the slope? Do you guys remember? It's the derivative of y. So you take the derivative of x sine x. What kind of rule do you guys use for this? Is that product rule? Okay, so you got the derivative of what? Sine, and then you factor out your sine. Take the derivative of x. So what's the derivative of sine? Cosine. What's the derivative of x? 1. X cosine x plus what? Sine, okay? So this is your M tangent. Now, what do you guys have to do?
Plug in.
You got to plug in what number? The first one. What's the first one? Plug in pi over 2. Is that right? Okay, so you plug in pi over 2. So then that's going to be what? Pi over 2 cosine pi over 2 plus what? Sine pi over 2. What's cosine of 90 degrees? Do you guys know what that is? That's what? Cosine 90. Is that 1? I think it's 0. Is that true? What's sine of 90?
Sine of 90 is 1.
Sine of 90 is 1.
Cosine is 0, 0.
Yeah, I think so. Something like that. Oh, M tangent's 1 again? How boring. See, when I make it up, it gets boring. Trying to make up these questions. All right. Boring kind of question, so sorry. Sorry to bore you guys with these. Y minus y1 is M what? Tangent x minus what? X1. So the thing about this is, you know, your x1 and your y1 are the same in these examples, so sorry for making it so boring. Anyway, so put what? Pi over 2 for both. And then that slope is 1, is that right? So you get what? Y minus pi over 2, 1x minus what? Pi over 2. So y minus pi over 2 is really going to be x minus pi over 2. And again, you get that boring equation, y is x. All by accident. Because I don't want to do the questions in your book. You guys know what I mean? I don't want to do your homework for you. You guys have to do your homework. You got to earn that. That's how you get those skill sets, right? And if they ask you for the normal line, again, it's going to be kind of boring again. It's y is minus x again, because the slope has to be opposite in sign and then reciprocal in value. So the slope for the normal line will be -1. And Where is this? What's this curve? X what? X sine x. So let's see what Desmos says. Do you have that on your phone? Y equals x sine x. Because I have it on my phone too. It's nice and free. And then I think this is what? See that there? Something's wrong. Oh, it's at a different point. Wait a minute. Where's pi over 2? Mm-mm. Did I do cosine? There it is. I apologize. So that curve is x cosine x. You guys see how that looks? The curve x cosine x? You don't study that curve in trig though. Like you say, I have an amplitude that's a variable. And then here's the, come on. Why does it not want to go on? It's frozen. Anyway, it's frozen. It's frozen. So, did we do x sine x?
Yeah.
What's going on here? At pi over 2, right? All right, so double check that here. Okay, let's go back to x sine x. Okay. And something's bothering me here. So here's sine x. You know what and at pi over 2, 3 pi over 2 here. So we're going to say, here's pi divided by 2. Yeah, where are you? Let's plot you. Pi over 2 is about it's about 1.5. So, somewhere up here. Okay, well, we're going to have to find...
So you could try to make it into an equation if you want to.
No, I mean, let's double check here. Cosine 90 degrees, is that 0?
Yeah.
Do we do the right derivative? Looks like we're fine, right? Sine of 90 is 1. So it looks like we're good. So, okay, well, we'll try to find what the situation is. We'll double check. Okay. So we're out of time, ladies and gentlemen, and we'll see you guys when? Tomorrow. Okay, so make sure you guys are finished with all your what?